Here are the conditions involved from the power source, spinning alternator with no field energization and a pretty balanced load. We're drawing about 0.3 amps on all three delivery lines, 0.9 volts phase 1, 1.3 volts phase 2, and 0.9 to 1 volts phase 3. Shorted out everything involved in the former experimentation with the 666 machine, and at the end of all of these shorts we have a 3-coil system, pancake coils. These pancake coils, phase 1's in front, phase 2's off the left in the middle, and phase 3 is in the back. Speaking also, those are the respective amperages being recorded on all three of them pancake coils. What the shell game involves is to place these coils in arrangement in space so that all three of them will go down. And as we will see, that with those 3 coils alone, that seems to be impossible. So we've figured out a way to work with it. And more importantly, now we want to go to our scopings. We want to note that at an approximate 1 volt level is in fact the amperage that we attain to in its somewhat isolated state of mutual inductance. Now we have a scope. Hopefully we place the scope close enough to see what might be termed a paradox. Right now the scope's on, 2-channel observation. And what we have is we have a sensor coil identical to the actual coils that we're energizing with the 1265 hertz from the alternator. And we're on 2 channels, and obviously we're seeing a 120-degree difference in time from the front and the back coil sensors. Now we'll go in there and turn that coil over. We turned our scope sensor coil over, and now we should be able to see the signals are much closer in phase. Now what we're going to do is we're going to look at just channel 1. Actually, channel 2. There's channel 1. Okay. There's channel 1. Now we're going to turn the sensor coil over. There's no phase difference. It doesn't beget 180 out of phase just by turning it over. And in fact, it doesn't matter whether we turn the coil over or put it in below the magnetic field. But we're going to leave it on top for now. We're going to leave it on top because we're going to stack all 3 coils together to create a torsional field device. And when we do this, we're going to watch our amperage levels. Now we're going to go back to coil number 3 and demonstrate the same thing. The one in the background there. Change our channel. See the phase shift. And we went to the other channel. Now on the other channel we're going to demonstrate the same thing. On this channel we have the sensor on the bottom. Rather than change the sensor on the bottom, we'll simply turn over the source. And as we turn over the source, we should not see any phase change. So we see that the orientation of those sensors do not change when they're recording on single channels, no matter whether on bottom or on top, whether the source or the coil sensor itself is turned around in space, it's all the same signal. So then why? We go back to our 2-channel observation. Well, before, it didn't matter how we change things around, it's the same signal, but now it does. So we'll turn that back around again. Okay, we know that's the incorrect signal that we want to be monitoring for 120 phase angles, and so we're going to put that back to so it's showing at 120 degree phase angle. Now we can get back to the shell game now. We've got 0.17 and 0.18 millimeters. We'll start stacking things together. First we're going to stack 2 on top of 3. We're going to note our input conditions. We know we've got this peculiarity of 1.3 volts being in the middle from the unenergized field. Now we're going to leave that there for a second and stack that. Note the change in our input conditions. As we see, the input conditions dictated a loss of inductive reactance. We'll go and stack, we'll quickly note that stack there. And what we're seeing on the scope is on the second. Now we're going to go ahead and look at our input conditions again. And we see that all of our amperages have gone up except for the third one. We haven't moved the third one yet. Move the third one. And we see that all of our input amperages have gone up in the stacking. Here's the amperages of the source having changed after that stacking. Now we want to go and look at the results on the scope of that stacking. On that stacking, we see that now the magnetic field coming out to the bottom of the coil group is not as powerful as the one coming out the top. And this of course is due to the fact that all of our amperages went up. However, when we stacked it like that, that was for 3-phase cancellation. So essentially we're puzzled. Well, all the magnetic fields are canceled by opposite amp turns in time. Well, we've still got stuff coming out the poles. And when we tried to cancel that amperage, we got non-symmetrical results with our amperages. Now quickly then we're going to go in there and reverse the middle phase 2 coil in this arrangement. That will resemble the principles of the 666 machine, whereas now is what we call the principles of the 663. And there's what we get with that. And those are the magnetic fields above and below the assembly. And here are our amperages on each coil. And we see that the 2 left ones may have gone down slightly, but the third one's still higher than its solitary state. Here is the input now for that condition, what the shell game's all about. is we want to stack them things in a way or figure out how to make all three of the amperages go down. Thank you.